Find the dimensions of the rectangle with the largest area that fits above the graph of the parabola y equals to x squared and below the line y equals to 3, so that the top of the rectangle is on the horizontal line y equals to 3. So let's look at parabola. Okay, y equals to x squared, and look at the line y equals to 3, and we want to consider rectangles inside this area. So for an example, we have an rectangle like this. We could have a rectangle like this, or we could have a rectangle like this. Okay, so for the rectangle, we need to consider the area, and the area of a rectangle is length times width, right? But what is the length and what is the width? Well, we gotta think of the length and the width in terms of x and y, or just x. So here we can say, okay, let's say the length is going this way and the width is going this way. So if we have the length, let's say here, and here's x, right? The length of this would be 2 times x, right? So here's x, and here's negative x, right? So this would be 2x, that would be the length, okay? And then the width would be this height right here. And what is this height? So the height would be y minus this x squared, right? So here the height would be y minus x squared, right? The line above and the line below. So that's the height. Okay, so here I'm going to write the width is y minus x squared. Okay. Sorry, not y. Y equals to 3 minus x squared, because it's that line y equals to 3. And sorry, I meant to say 3, not y. 3 minus x squared. So the line above is always 3, and the line below is the parabola, right? So we have, these are some possible triangles. I'm just shading in so you know which one I'm looking at. Okay, so this is the width. So this is width, and this is going to be equal to, well, this is length. The length is 2x and width is 3 minus x squared. Okay, so we have that, and now we want to find what is the maximum area of the rectangle. So to find the maximum, we need to optimize, and to optimize, we find the derivative and set it equal to 0, and that's pretty much what we do. So let's do that. So find the derivative and set it equal to 0. So we're going to find derivative. Actually, I'm going to write something else. To optimize, we will take the derivative, and set it equal to 0 and solve for x. Pretty much solve for the critical points, i.e. solve for the critical points. Okay, so let's do that. So ax equals to, actually before I'm going to do that, I'm going to rewrite this. I'm going to expand and simplify. Bring this out, expand it. We will do 2x times 3, so that's 2 times 3, which is 6x, minus 2x times x squared will just give us 2x cubed. Okay, so I'm going to find the derivative of this. And it's easier to do this because I don't have to use the product rule. I can just use the power rule and take the derivative directly. Okay, so I have a equals to this, and I'm going to take the derivative of that. So I have a sub x equals to derivative of, I'm missing a number, sorry. There should be a 2 here. So the derivative is derivative of 6x, that's just 6, minus derivative of 2x cubed, so that's 2 times 3, which is 6x, and then subtract 1 from the exponent. So that's the derivative of a with respect to x. And so now I can factor and simplify. So I have 6 factor, we have 1 minus x squared, and then again 1 minus x, 1 plus x, and all I'm doing is factor. And this is a difference of squares. Of squares. That's just kind of a trick. So we have whenever we have like a squared minus b squared, this is just a minus b, a plus b. And then we're going to set it equal to 0. So a sub x equals to 0 when we have 6, 1 minus x times 1 plus x equals to 0. And pretty much we just isolate and solve for x, right? Here it's easy since these are all factors. So this equals to 0 when one minus x equals to 0 or 1 plus x equals to 0. And then we can just isolate and solve for x. We'll move the x to the other side. We'll just have x equals to 1 here, or x equals to negative 1. Okay. Now, notice here, what are the values of x? Well, x, if we're considering x as a length, then x would have to be in between 0 and this number here, right? So we'd have to consider, okay, what is that? That is, y is 3, so x has to be square root of 3. Okay, so let's just note some things down here. This point right here, this is x equals to root of 3, right? And so here I'm just going to say here, note that since x is a length or measurement, then x has to be greater than 0, okay? Greater than or equal to 0. And then also, since the rectangle is under y equals to 3 and above x squared, right? It's below x, y equals to 3 and above y equals to x squared. Then what is the condition for x? Well, x has to be less than or equal to root of 3, right? Because if it's somewhere out here, it won't be within that parabola. So it has to be less than root of 3. Okay, so what do we have? Okay, well, this one doesn't work. This answer is negligible. Negligible, just meaning that negligible, just meaning that we can ignore that one. And then it must be that x equals to 1. Okay, so therefore it must be that x equals to 1. Okay, so we didn't answer the question yet because it says find the dimensions of the rectangle with the largest area. So we need to find the dimensions. So what are the dimensions? We need to find what is the length and the width. We found x, but we need to know what is the length and the width. We said length was equal to 2x, right? And width was equal to 3 minus x squared. So let's say recall length is that and width is that. So this means that we have length is 2 times x. So we have 2 times x. 2 times 1, and this is just 2. And width is 3 minus x squared, so 3 minus 1 squared. So this is 3 minus 1, which is 2. And so this means that we have this. Okay, so the length, so to answer the question, we need to say, what are the dimensions? Dimensions of the rectangle with the largest area is, so the dimensions of the rectangle with the largest area is 2 by 2. That's your answer. Or you can say this length 2 and width 2.